In this video, I'm going to go over how to create procedurally generated rocks in Houdini. The end result will be something like this. Yours will undoubtedly look a little bit different, but the process will be the same. I have multiple different rocks that will be generated based on the frame number that we're on, so it's a really good way of creating a lot of rocks that are very similar, just with a different shape without having to go in and actually do individual rocks. And it's actually a fairly simple setup. I start with just a platonic solid and turn it into points. There's only a few points in there. And then I'm using those points to fracture. And what that does is it just gives me some random shapes. So with the exploded view, we can see that each one of these shapes, which is now 7 unique objects, will be turned into a different rock. I can very easily change the amount of rocks that I have just by changing the amount of points. So I can have a very unique setup. So now with a lot more points, I have a lot more rocks that I could possibly export. And then all of that, or all of those shapes, are being put into a for loop. So we have a for each connected, and what we're doing is very simple. We're centering the objects, turning it into a volume. That's mostly just so we can have a more evenly distributed face, kind of face distribution, because if we look at here, we can see it's very uneven sized. If we subdivide it now, it'll be very uneven. It won't displace evenly. So what we can do is just have a lot more polygons. Then I'm remeshing it a couple times, getting into quads, giving it some UV coordinates, and then subdividing it. And this is how we can get our low poly and our high polys. So our low poly would just be set to 0 subdivisions. Let me turn off the UVs. And then high poly, probably bring that up to 7. And then this attribute VOP is where all of the distortion happens to actually make it look like a rock. This is a lot of nodes inside of it, and we'll definitely go over that in a lot more detail later. But what it does is it's just displacing it using different noise patterns, and then the more we subdivide, let's bring that up to 7, it'll take a moment for it to actually calculate. There we go. We can see that we have a much higher poly, very nice rock. The cool thing is this high poly rock has the exact same UVs as the low poly because the UVs are happening up here. So if you needed a level of detail, you could very easily swap them out. I'm going to be using the high poly to bake onto the low poly, so I don't necessarily need UVs on the high, but they're there just in case. And then we have an export node, and we're just going to be exporting based off of how many frames that we have. So it sounds kind of complicated, but let's go over how to set this up. So I'm going to go just make a new project. And I first just want to start off by making a shape. So I'm going to hit tab and type in geometry because I need a geometry node. And I'm going to double click on this geometry node to go inside of it. And this is where I'm going to actually make the object that I want. And it doesn't really matter what shape you start with. I'm going to start with a platonic solid. There we go. The more you type in what you want, the more it narrows down the search. So now I have this nice little four-sided object. For the solid type, I'm going to change that to a dodecahedron, so I have 12 sides. And so far, so good. I next need to turn this into polygons, or I'm sorry, into points. And to do that, I'm going to create a points from volume. So I'm going to hit tab again, points from volume. And I'm going to connect the bottom node on my platonic solid to the top where it says required geometry to fill with points. So every now and then it tells you exactly what it needs. This node needs geometry. And when I do that, I don't see anything. I need to hit the blue display flag on the right-hand side to make sure I'm viewing that current node, because right now I'm viewing that platonic solid. I want to view the points from volume. So I have a lot of points. This would be a lot of rocks. So I'm going to turn up that point separation a bit. And right now it's very evenly distributed. They're all in a perfectly straight line. So I'm going to go down to jitter seed and jitter scale and just move them around so it's a little bit more random. So that's looking good. And this can change later. Your values do not need to match mine, nor should they match mine. And it can change at any time during the process. Then the next thing I'm going to make is a fracture. So it's going to be a Voronoi fracture. Not sure if I'm pronouncing that right. And then I'm going to connect the platonic solid to the first input and my points from volume into the second. And again, I need to hit the blue display flag. And what that does is it looks like it just multi-cuts it. It just cuts it up into different pieces. If you're not seeing your wireframe, you can come up to this little cube on the top right of your 3D viewport and go down to flat wire shaded. If you're in flat shaded, you'll just see your geometry, but sometimes it's nice to see your wireframe as well. So what did that actually do? I'm going to make a node called explode, exploded view, and connect the output to the top of it, and then turn on the view display so I can see that this is exactly what it's doing. It cuts it up all the way through. And each one of these rocks will become, or each one of these pieces will become an individual rock. The exploded view doesn't actually matter for what we're doing, it's just a nice visual way of seeing what we're doing. So I'm going to put that over here. The rest of the steps that we're going to take are going to happen in a for loop, meaning for each one of these pieces, it's going to go through and do all of the steps. That's how we can have a lot of randomly generated rocks very, very quickly. So I'm going to hit tab and type in for each, and I want each connected piece. And it gives us this nice little for loop. Start and end is inside the orange box. And I'm going to put my fracture node just to the top of the connectivity. So right now, it's not doing much at all. Actually, it's not doing anything at all. But it is set up. And there's a lot of things we need to do before we start making it look like a rock. The first one is I want all of these individual pieces, so all of those, to be at the center of the grid. So they're all in the exact same place. And to do that, I'm going to create a node called match size. And I'm going to bring it inside of the for loop. And if you just hover over some nodes onto this connection path, it'll automatically make the connection for you. And what it's going to do when you turn on the display flag is it will show you just one of those pieces, and it will show it right in the center of the grid. So the X, Y, and Z are all set to center. If it's not set to center, just drop down and go center. So now all the rocks are at 0, 0, 0. The next step, we're going to turn this into a volume. So right now, this is just normal polygons. Nothing on the inside. It has not great topology. So I'm going to create a node called VDB from polygons. And this is going to create a volume out of polygons. So I'm going to connect up here. I'm not going to connect it down to the end right now. There's going to be a lot more nodes to come. I'm just going to turn on the display flag for this. So it looks not great. There's a few things that we need to change. First off, the voxel size. That's how big are those volume pixels that this volume is made out of. The bigger the number, the bigger the size. Smaller the number, the higher resolution it looks. I would recommend not going all the way down. It will kind of stress out your computer a bit. But 0.005 is looking pretty good. And I'm going to turn on fill interior. This will make sure we don't have any holes in some of the next steps. Actually, for now, I'm just going to go to 0.05 just so it runs a little bit faster. And again, this can change later. And the main reason we're creating this volume, if I turn on the wire shaded, oh, won't have it yet. But when we convert back to polygons, so we convert VDB, and connect it up. I want to convert to polygons. We now have a lot more polygons to work with. And they're more evenly sized. Not great topology, but they're more or less evenly sized, which is nice. I'm going to make a remesh node. I'm actually going to make two remeshes. The normal remesh, and then the quad remesh, which in this version of Houdini is still in beta, but it seems to work okay-ish. The first thing I'm going to do is connect my convert VDB to the remesh, and that gives us triangles. You can turn on more or less iterations or more or less smoothing to get a slightly different shape. But I don't really want to work with triangles. They don't subdivide perfectly, and it'll make the distortion look not great when we turn on the get into the next few steps. So the next one is the quad remesh. What it does is just converts it to quads. I tried going directly from the VDB to the quad mesh, and more often than not, it got some areas where it was stretching and breaking. And I don't need this to be 10,000. We're going to do a smooth later. So I might bring it down to 500 and just have a nice low poly version of this rock. Also give it kind of a once over, make sure it's not breaking anywhere. I didn't always get the error when I went straight to the quad mesh, but it seems to be much less common when I go to the normal remesh and triangles and then go to the quad mesh. And this doesn't have to be 500. It can be lower, it can be higher. It really just matters for what you're going to use it for. And then the next step is going to be a UV unwrap. We have a UV unwrap node. I'm going to plug it into that first node, turn on that display flag, and we have our UVs. If you're not seeing your UVs on the right-hand side of your display port or viewport, you have the show UV texture when UVs are present. It's a little checkerboard. You can turn it on. You can also hit spacebar 5 and you can view your UVs. It's just an automatic UV. They're not great. You can change the amount of planes. You might get something better, but it's not going to be perfect. But that's okay. We can always fix it later on if we need to. I'm going to hit spacebar 1 to get back to my perspective view and turn off my UVs. Next, I'm going to create a subdivide. And all that does is every one face becomes 4. I'm going to have it set to 0 for right now. And this is how we make our low poly and high poly eventually. So we have a fair amount of stuff in our for loop. Right now, if this was it, it would go through and we would have a nice quadded version of our rocks, a lot of low poly rocks, if we just went directly to our end of the for loop. However, we're going to create a much higher poly rock with a lot of good detail. And to do so, I need to create something called an attribute VOP, VOP. So attribute VOP, there we go. And we have a very special node, which is kind of like a window into Houdini's programming or scripting language, Vex. This allows us to do some visual scripting in it. And I'm going to connect it to the first one, and it does absolutely nothing by default. But if you double click on it, you have the ability to create lots of nodes inside of this node. On the left, we have the inputs. So this is everything being inputted. And then on the right, we have all of the outputs. Right now, there's no connections. Nothing has been made. What we want to do is create different types of noise to displace different parts of the rock. So I want to have some displacement in the y direction going up and down that's different than the x direction going around the rock. So I want to have two distinct types of distortion of noise on this rock and then combine it all into one output. And to do that, it's a lot of steps, but hopefully not too difficult. Before we get into the really complicated part, let's just do something simple so you can see what it's doing. So I'm going to create a turbulent noise. So turbulent noise. And I'm going to put the position value in. And just so you know what position value is, let's go over, I'm just going to, before I use the noise, connect the P over to CD, which is color diffuse. So this is all the position value is. It's saying, where is it? It is the, right now on the left, it is the original position of all of these points. And on the right-hand side, oops, it's going to be the position, the new position of the points after we do everything. And we're going to be using the position, the P, as well as the normal, this N value. So if I take the N and drag it over to the color, we can see these are the normal values. And what the normal values are, I'm going to jump to Maya real quick, is I have that rock. And all of these different face normals are in a different direction. Each of those directions have a different X, Y, Z coordinate direction they're pointed in, and those are converted to RGB data. And we're going to be using both the position and the normal data to figure out how it's going to be displaced. The normal is for the direction it is, and the position is going to be where those points are moving towards. So for the turbulent noise, I'm going to take the position value and plug it into the position over here. And I'm going to create one more node called a displace along normal. And I'm going to take the turbulent noise, the noise value, bring it into amount. And then for, sorry, I just got a pop-up on the monitor that was distracting. For the normal value, I'll take the N, and it's going to go all the way over to the normal attribute input over here. So now when I connect that displacement node, so displace P to the position value, we can see this is what the turbulent noise is doing to our rock. If we come back to the turbulent noise node, we can turn down that amplitude, can change the roughness of the surface, all sorts of things. If I hit U to go up to the main graph or hit this little GO1, I can go to this subdivide node. I'm just going to subdivide it so we can see a little bit more detail of what's actually happening. So we turn off the wireframe and go back into our BOP. So here is our noise. Can change it. You can go negative if you want to bring it in. If you go negative, you will get a lot of overlapping and kind of broken geos, so do be careful of how you use the noise values. And overall, this is what we're going to be doing. We're going to be creating different noises and displacing them in different ways. We're also going to be using a vanes noise. So for that, position, and then the normal is good. I'm going to replace the amount. I'm going to use one of these, a little bit intense. Let's bring that down. And it's just a different type of noise to get a very different kind of feel for it. However, what we want to do is split the vanes so they go around the rock, so in the X and Z, and then have this turbulent noise in the Y direction for the top and bottom of the rock. So I'm going to delete those nodes. And I'm going to create something called a normal, a vector to float, sorry. Vector to float. And we can input a vector, which is going to be our normal. And that can break it up into X, Y, and Z. So it goes in the same order as most software, X, Y, Z, top to bottom. So I want to have the value 1 and 3 together, and then value 2, which is y, as its own. So I got my vector to float. I'm going to have a float to vector. And I'm going to hold down Alt, left click, and drag and release while still holding down Alt. Just have a second one, or you can just create another one. And I'm going to have this one be my y value, and this one will be my x and z values. So value 2 goes up here, and then value 1 and 3 go down there. So I'll pretty much try to split that normal into two different vectors. I'm going to create a displace along normal. I'm actually going to have two of them, one for each of these. And the reason we have two different displacements is the y is going to have its own displacement, and the x and z will have its own displacement, so we can control them individually. I'm going to start with my x and z, and the one output that it has, this vector output, is going to go into the normal, marked by the lowercase n, capital N. And then the displacement 2, the displacement position, is going to go up to the position of the displacement up here. So this is the displacement x and z, and this will be displacement y. And then the float to vector for my y value is going to go into the displace y normal value. And then my final, or the displace along y, the displace p, is going to go into the position value. So right now it's not doing anything at all. But what it's doing is giving us control over the y displacement and the x and z displacement. And then we are combining the position values of both the x and z and y together, so we can have one position value for the output. There's no noise right now, so if you're wondering why you're not seeing anything, it's because we haven't done anything to actually distort the position value of the points, but we'll be doing that in a moment. And that moment's actually right now. So let's create a turbulent noise. And I'm going to start with the y value. It's a little bit easier. I'm going to connect the position up to the position of the turbulent noise. And then on the displace y, this noise value is going to go into the amount. So already we can see we have some displacement going only in the y direction. There's a little bit on the sides here, and that's because there's just a little bit of y normal information here, but overall the sides are fairly smooth. We can go and we can change the amplitude. If you're not seeing any displacement after connecting these, go back to your geo and make sure you have the blue display flag turned on your attribute VOP, because if it's still on the subdivide, you're not going to see anything in your VOP regardless of what you do. So make sure the display flag is turned on, and then you can go back and then hopefully you'll see some noise. And again, you don't have to get your noise dialed in perfectly right now. It's very hard to know exactly what it should be before we have all of it. And the nice thing is we can go back and we can change these values whenever we want, which makes it very easy to make some subtle changes. So for the y, that's actually all I'm going to do, is just that one turbulent noise. The x and z, we're going to have a little bit more. We're going to have a turbulent noise as well as a vanes noise. So I'm going to create the vanes and the turbulent noise. Let's have both of them right now. And I want the same position value here going into both of these, which it can be kind of messy to have all these lines everywhere. So you can make a node called a null, which is kind of like a good way to not redirect, just kind of organize a little bit. So now I have the position going in here. I'm just going to connect the position to both of these. And right now, let's just work with the veins. I'm going to create a temporary displace along normal and connect the amount to the normal. And then the output I'm going to bring over here just so I can see what the veins are going to do. I think I accidentally said connect the amount to the normal. I want the amount going to the amount, and now we got a lot of displacement. Let's turn that down. There we go. And again, there's not a right or wrong way of doing this. It's whatever looks pretty good. And once you have something you're pretty happy with, if you middle click and hold on any one of these inputs, you can just drag left and right and you can change the values. It is still kind of sensitive, but be a little bit easier than just typing in numbers. And I also have this turbulent noise, which if I connect to the amount, doing pretty much the same thing as the other one, this one's going to be much more subtle. I don't want it to be very intense. You also have different types of noise. By default, set to alligator noise. You can do Perlin, all sorts of different types of noise, depending on what looks best. May have it set to 4, then fix some of those values. There we go. And I do want these to be combined together, because right now they are two separate values, and I want them to all go into my x and z. I'm going to create or delete this kind of temporary node that I made and just fix this. There we go. And I want to add the veins and the turbulent noise together. And to do that, I'm going to create an add node. And it's very simple. The amount goes into input 1, and then your noise goes into input 2, and now they've been combined. I need to put them into the displace x and z, and I want them to go into the amount. So the sum of the add node is going to go into the amount. So you can see that we're now getting that displacement, the x and z, and then it's being combined with the y going into our output. And then this is where you can go back and you can figure out exactly what type of noise, what you want everything to look like. A lot of different options, not one thing that is correct. So once you do that, we'll come back and go over how to export. So I made just a few changes to just my veins node. I turned the noise frequency and the Y up a little bit to get some more of this kind of layering look. If you want to see what it looks like with a higher resolution, because right now I'm looking at mine pretty low res, hit U to go back up and click on your subdivide and maybe bring that up to 5 instead of 4 or whatever kind of has the detail you want. So you can see that we do have a lot of nice detail in there. Just hard to see when it's set really low. You can't see any of it. It does go a lot slower when you have more subdivisions though. I have some layering that I like, got a lot of noise, no layering on the top, which shouldn't have any. I'm going to turn down the Y noise just a little bit, or maybe change it to Perlin. Yeah. Cool. So I have stuff in my VOP, and it starts over here. This is the original, and this is the new position for all of the points being displaced by all that stuff. Back in our for loop, where you can actually finish our for loop. So I'm going to bring this up a little bit, connect the attribute VOP to the for loop down here. You don't have to do much on the end of this for loop at all. However, do turn on the checkbox next to single pass. There we go. And what this does is tells it, basically we can connect this to a frame number. So the single pass where it says 0, if I type in $F, it's going to now be connected to the timeline. You can see my rock just changed. And down here on the timeline, I'm going to just bring this down to 10 frames, just so we don't have 240. And this actually starts at frame 0. And if I go to frame 0, I'm going to have a rock. If I go to frame 1, I have a different but similar rock, frame 3, 4, 5, 6, however many you have. I don't think I have very many points up here for my original exploded view. So I only have 4 different versions. You can very easily increase that to however many you want. And now we just have to export. So I'm going to create something called a ROP geometry output. And I'm going to connect the end of our for loop. And over here on this, let's change that size. I don't want to render the current frame. I want to render frame range. And right now it's going to do, by default, 0 to 10, because that is what my timeline is set to. I don't actually have 10 rocks. So if you do Control, Shift, and left click, it just removes that connection, and you can say, I want frame 0 to 4, or 0 to 10. Actually, I just need frame 0 to 3. There you go. And this will allow us to export. So I'm going to click on this little arrow sign so I can tell it where I want to export to. And let me just delete those. All right, so I made a new folder. I just call it rocks for loop. That's what I'm doing. Then for the file at the bottom, that's the name. So I'm going to call this rocks. For now, we can change that name convention in a moment. And right now, if I export them, they won't have the frame number on them. I won't know if they're low or high. So we need to fix that. I'm going to export my low polys first. So I'm going to go up to my subdivide node and turn subdivisions to 0. And then down here, I have rocks. I'm going to type low and then $f.obj. So it's rocks low frame number, so 1, 2, 3, 0, 1, 2, 3, and then they'll be saved as an obj. I'm going to hit save to disk, and I have those low poly rocks exported. If I jump into Maya real quick, I have down here rock number 1, rock 2, rock 3, and rock 4. These are my low polys. I'm going to jump back to Houdini, go up to my subdivide, maybe change that to 6. See how that looks. Good enough. Going to go to my geometry export, and same naming convention. I'm going to get rid of the low and type in high. This will take a little bit longer to export because it has to calculate the high poly kind of graph for everything. So let me pause. All right, so I now have all 4 of my high polys. So I'm going to drag in one at a time because it will take a little bit longer. And now they are ready for pretty much whatever we need. So I'm going to move the low and highs together so I make sure they're still on top of each other. I'm gonna put them in a nice row. Two. I'll leave the 2s there and get 3 and move them over here. So I take the lows and isolate them. Here are my lows. I'm gonna do a soften edge on them so they look a little bit smoother. If I go to my UV editing, the UVs are all on top of each other. If you were doing level of details or you needed to have the low poly swap out for the high poly with the exact same texture, I would skip this step. But I'm just going to be using the low poly or the high polys to bake in Painter. So I'm just going to do a layout so I have all of these UV shells on the same 0 to 1 space. I would recommend probably cleaning up some of these stray faces, little UV islands around. I can do that later. And if I look at my high polys, don't need their UVs, so I'm just going to close those. And we have all that nice detail. To get into Painter, I'm going to have a group. You don't need a group, but I like to organize like that. Low poly, going to make sure they have the same material on them. So assign favorite, Lambert, and this is to be called N rocks. I'm going to go to export my selection. Rocks for loop. They're FBXs, so these are going to be rocks low. Select the highs. And rocks high. And I'm just going to go over the baking in Painter. I'm not going to go over texturing. That part's not too bad. I might do a little bit, but mostly want to make sure the bake works before moving on. All right, so I'm in Painter. I'm going to go to File, New. Not that rock folder. I have many rock folders at the moment. There we go. I have my rocks low. That's what I want to bring in. I'll just leave it to 4K for now. Hit OK. Make sure you have all the rocks, same UVs. If you ever see your UVs move around, it's probably because something's not UV'd and Painter is auto UVing it, but there were no errors. Everything looks the same, so that's fine. I'm going to hit F8 or the little croissant icon, and I'm going to load in my rocks high. Might take a moment because it is a fair amount of geometry. If you see any red on your rocks, so if it looked like that, that means that anything red can be left out of the bake. So I'm just going to make sure that max frontal distance is turned up enough, which by default it was. I don't have an ID, so I'm going to turn off ID, but I'm going to turn on height, so I get that. And don't need any matching, but I will turn on anti-aliasing to 4. And now I'm going to bake. Should go pretty quick. If it's only baking some of the rocks and not the others, make sure you have one material assigned to everything. It will bake, if there's 4 different materials applied, it will bake per material. But now we can see that our low poly rocks have pretty much all that same detail that the high polys have. And instead of being a file that is 475 megabytes, it's 135 kilobytes, then plus the textures that we eventually export. One tip for texturing, try to avoid materials that already have a lot of detail on them, so a lot of height maps and a lot of stones already cut in, because we already have that from our high poly bake. So finding material that's relatively flat without a lot of detail is actually really nice. So this large stone, limestone, can be kind of good. I'm going to change it to triplanar projection, and I'm going to turn off the height because it's causing that weird little glitch there. And then you can go through and figure out what tiling looks good for your rock. And I have normal and height turned off on mine because I have pretty much all the information I want normal-wise through there. just through the bake. The triplanar doesn't look perfect everywhere, but depending on how important this rock is in the scene, people probably won't notice the striations going different directions. You can also, if it looks good going around the side, you can mask by direction and have a different material on the top and bottom that blends together. But you generally want to avoid things that already have a pattern and normal information because it won't match the bake that you have. And then once you're done with that, you just want to export your textures for whatever game engine or render engine you are going for.